So, how did we get to this powerhouse of big data unification? We've already talked about MapReduce, which was popularized in 2004 when a paper on the subject was released to the public. That and other ideas led to the birth of Hadoop at Yahoo in 2006. But, as we've already mentioned, that was only the beginning of modern big data computation, as 2009 brought along Matei Zaharia and his creation as a PhD at UC Berkeley, namely Spark. Then, in June of 2010, he released his research paper on the project, titled Spark: Cluster Computing with Working Sets, following up later that year by releasing the project as open source under the BSD license. The project began to gain ground while still being incubated in Berkeley's AMP-Lab as part of the Berkeley Data Analytics Stack, or BDAS for short.
The AMP-Lab was created as a 5-year endeavor starting in 2011, spun down at the end of 2016, rolling into the real-time security-focused RiseLab. Its goal was to find the best solutions for these big data problems,
focusing on algorithms, machines, and people, thus AMP. And Spark fit that agenda well. It continued to pick up some real momentum in the community, and in 2013, Matei and a number of the prominent Spark collaborators founded Databricks, a company focused on supporting Spark as an open source product and commercializing parts of this burgeoning big data world. Keeping up momentum, that same year, Spark switched its license to Apache Commons 2.0, very quickly graduating to a top-level Apache project as of 2014. That same year brought Spark the record for large-scale data sorting, as mentioned earlier.
Then, in 2016, the 2.x branch of Spark was released, making sure it remained up to date in this ever-changing world of technology.
And, as it's still one of the most active big data projects, it continues to grow and break down any big data walls in its way. Its Apache licensing and the founding of Databricks is a big part of its growth, as it provides certain assurances to enterprises that Spark will be a stable framework to utilize. While the Spark community is very active, a vast number of the improvements for Spark do still come from those within Databricks, and they've set their focus on continually improving Spark while keeping it stable. In fact, everything that is not marked as an alpha product or a developer API
in a major version of Spark
should be backwards compatible, even with an attempt at binary compatibility within that branch, which means that a Spark upgrade would not require rebuilding your project. And even within any alpha project, breaking changes are clearly documented as part of their documentation of each release. They take such precautions in this vein that they've even built a custom tracker which causes any breaking changes in the API to result in a build failure, as well as prominently display any new public classes added by a change set. As of this recording, I believe this is one of a kind for open source automated build systems. As far as the versioning itself, they keep a structured, reliable build schedule, building a new minor release
every 6 months,
favoring consistency of time over features. Any features that don't fit in the 3-month time frame will simply fall to the next release. Of course, there's a slight caveat with that, in that each new release must go through the Apache voting process. However, that hasn't caused any notable slowing of the cycle as of this recording. These releases often contain new features, while patch releases are used to keep past versions up to date on a less strict schedule, making sure that any important bugs are squashed along the way. This dedication to reliability, stability, and performance has not only helped bring a dedicated community of contributors, but also an ever-growing community of users. Spark's generalized abstraction and growing helper libraries mean that companies can use Spark for a vast number of usages, such as Pandora's real-time recommendation system. Recommendations and other personalizations using big data are definitely a vast use case, covering companies such as Yahoo, Comcast, Ooyala, Conviva, and Netflix. In fact, Netflix even tested Spark against Chaos Monkey to check its resiliency, and they were happy with the results, excited to take it to the next level. Another case is with the load of data crunching for real-time threat analytics, such as different types of fraud detection. And of course, there's the case of log aggregation and analysis being done at eBay. Then, there's Twitter's usage for graph analysis of social networks. And my, along with many others' favorite usage is the many areas of science exploration, such as Freeman Lab at Janelia, where they're using Spark for analyzing and visualizing patterns of brain activity in real time. Big data has already helped towards difficult medical diagnoses and could lead towards curing diseases such as cancer. Spark's usage seems to only be limited by the extent of your imagination.